Welcome to AI Unraveled, the daily briefing that dissects the business of intelligence. Today, we're switching to special episode status for a deep dive into the single biggest strategic hurdle facing enterprise AI, data gravity. You have petabytes of proprietary data, the real gold for training specialized LLMs, but it's glued to your current cloud provider. The best new models, however, are on a different platform. Moving that data is a logistical and financial nightmare. You're forced to choose performance today or freedom tomorrow. In this episode, Data Gravity versus Cloud Agnosticism, we explore the cost-benefit analysis of vendor lock-in. Is the lift from a specialized LLM worth sacrificing your architectural freedom? We're breaking down the architecture of the hybrid AI solution, the strategies and tools needed to train on petabytes without marrying yourself to a single tech giant. This isn't about code, it's about billion-dollar infrastructure decisions. If you're a CTO, a chief architect, or a builder deciding where your company's intelligence will live for the next decade, you need to hear this. But before we start, stop marketing to the masses. Start briefing the C-suite. You've seen the power of AI Unraveled, zero noise, high signal intelligence for the world's most critical AI builders. Now, leverage our proven methodology to own the conversation in your industry. We create tailored, proprietary podcasts designed exclusively to brief your executives and your most valuable clients. Stop wasting marketing spend on generic content. Start delivering must-listen, strategic intelligence directly to the C-suite. Ready to define your domain? Secure your strategic podcast consultation now. Link in show notes. Stay with us. The deep dive on building truly portable AI starts now.
Welcome to the deep dive. Today, we are grappling with this invisible but incredibly powerful force that is really shaping the future of enterprise tech. It started out as, a handy metaphor for data storage, but now, at the scale of petabytes, it's become a huge strategic challenge. We're talking about data gravity.
It really is a silent anchor. And data gravity is, at its core, simple physics. As a data set gets bigger, its, let's call it gravitational pull, increases.
Right.
And it starts attracting applications and, more importantly, attracting more data.
Yep.
It's a compounding effect, which means these huge data repositories are now they're too cumbersome and way too expensive to even think about moving.
And this is where we hit the paradox, isn't it? Because for decades, the mantra for big systems was always move the processing to the data, not the other way around.
Absolutely. That was the foundational rule. You did that to minimize latency, to minimize costs. And then Gen AI came along and just blew that rule right up.
Complete.
It really did. The most advanced processing, the specialized LLMs, the top-of-the-line GPU clusters, it all lives almost exclusively inside the public cloud.
AWS, Azure, GCP.
Exactly. And this forces every major enterprise into a direct fight with data gravity. They have to either move petabytes of their most sensitive data into the cloud, or they're effectively locked out of the best AI tools on the planet.
So our mission today is pretty clear. We're going to quantify the actual costs of this struggle, dig into the strategic traps, and then lay out a blueprint for independence, what we're calling the hybrid agnostic AI architecture.
Let's get into it.
Okay, let's start with the immediate pain points, because data gravity isn't some abstract concept. It has a direct financial weight to it.
For sure. It's a mix of latency, bandwidth, and of course, those direct costs.
And at the top of that list has to be egress fees.
Oh, absolutely.
Yeah.
That is the #1 financial tool they use to enforce lock-in. The cloud providers, they track every single byte of data that transfers out of their environment.
And when you scale that up, when you're talking about training an AI model, the numbers are staggering. We're seeing reports that moving just 1 petabyte, that's 1,000 terabytes, can easily mean a single bill for tens of thousands of dollars.
It's no surprise that, something like 56% of IT pros see these charges as just excessive.
Well, yeah.
And critics are pretty blunt about it. They say it functions as a deliberate data tax. It's a tactic to stop you from switching providers. It turns a simple operational decision into this massive budgeting crisis.
I can't imagine clicking approve on that expense report. Tens of thousands just to move your own data. And, okay, beyond the money, there's the actual physics problem. Performance latency.
Yes. Data-hungry AI workloads need to be close to the data. It's that simple. You can't run a complex analytics workload in the cloud and then try to query an on-premise petabyte database. It just doesn't work.
The lag would be unusable.
They would kill performance to the point of being useless, yeah. So you are physically forced to put your compute and your data in the same place.
And generative AI has just magnified this by what, an order of magnitude? It's the most data-hungry thing we've ever built?
That's the entire problem right there. If a company wants to build a really specialized LLM one that understands its own business, its research, its customers, that model has to be trained on petabytes of its internal proprietary data.
Okay.
The moment they move that data to the cloud to get access to the GPUs, they've just created a massive center of data gravity right there in the cloud.
And that's a one-way street, isn't it?
It's very difficult to reverse.
Yeah.
Once that data is in there, once it's subject to those high egress fees, it becomes, for all practical purposes, almost impossible to move.
Yeah.
So what felt like a short-term operational move is actually a huge long-term strategic commitment. You're handing over platform-level control to your vendor.
And that loss of control leads us right into what some are calling the LLM land grab. I mean, AWS, Azure, GCP, they are in a flat-out arms race to build these AI moats. They're trying to maximize customer dependency using proprietary services, custom APIs, and, yeah, those weaponized data transfer costs.
But there's a deeper risk here, one that's not as well understood. And that's the fine-tuning trap.
Okay, what's that?
So the providers are very quick to promise you that your proprietary data is not used to train their base models for other customers. And that handles the data privacy concern.
So my data is safe. What's the trap?
You're losing ownership of the intelligence you create. When your specialized model is done fine-tuning, the company doesn't get a portable file, the actual weights that you can download and run somewhere else.
What do you get instead?
You get a proprietary API endpoint. It just points to your model, which lives and can only live inside that vendor's ecosystem.
So you've essentially outsourced your company's brain. The unique knowledge you paid to create is now a sunk cost trapped in their data center.
That is the precise liability. If that vendor decides to change its terms or jack up prices or just get rid of a service, you cannot take your intellectual property with you.
Okay, but let me push back on that for a second. If I'm a big company and Azure or AWS is offering me the best GPU performance in the world right now, why should I care about being able to move in 3 years? Isn't speed to market worth that risk?
It's a fair question from an operational standpoint, but it misses the long-term strategic danger. Lock-in isn't just about moving. It's about leverage. If the vendor knows your core IP can't leave, they control everything. Future pricing, what features get developed, your whole architecture. You're sacrificing optionality, and that is an incredibly valuable asset to give away.
And when you look at it that way, their tactics feel a lot more deliberate. Like, let's take Amazon Bedrock. They advertise a custom model import for open source models like Llama. That sounds open.
It sounds like freedom, but it's not. Once you import it, that open source model becomes a proprietary Bedrock model artifact.
Yeah.
You can only use it through their proprietary API. So they didn't lock down your data, they locked down your model. It's maybe the most insidious form of lock-in.
And Google's approach with Vertex AI is a bit different. It's more subtle.
It is. It's performance-based. Vertex AI is so hyper-optimized for the GCP stack that if you try to use it with data that's not in GCP, you get what they call performance-killing friction.
So it's architectural peer pressure.
It's coercion, really. It subtly forces you to move your whole data stack to Google just to get the performance they promised you in the first place.
And then there's Azure OpenAI, which just leverages Microsoft's massive enterprise footprint.
Exactly. They tie the latest, most exclusive OpenAI models, the GPT series, directly to Azure. And since so many companies already run on Active Directory and Office 365, it creates this deep web of dependency that's almost impossible to untangle.
So we're not just talking about losing a bit of control. This is a dependency that becomes a perpetual cost center, one that the vendor can basically turn up or down whenever they want. Which brings us to the hard numbers.
Right, the TCO showdown. When you need massive AI compute, you're facing that classic choice. CapEx, which is buying your own hardware, versus OpEx, the cloud's pay-as-you-go model.
And cloud is great for experiments, right? For short-term projects or things that have big spikes in demand.
Absolutely. It's excellent for that because you have almost no upfront cost.
But what happens when AI stops being an experiment and becomes a core 247 part of your business?
And that OpEx model, that pay-as-you-go, it becomes this relentless, never-ending financial drain. The analysis is pretty clear. For consistent high-demand AI work, building out your own on-prem infrastructure.
The CapEx model.
Right. It can deliver 30 to 50% in total cost of ownership savings over 3 years.
30 to 50%. That's huge. And I've seen reports that the break-even point where buying the hardware actually becomes cheaper than renting it can be just a few months, not years.
The real decision here is about finding that perfect balance, and it really boils down to your #1 priority.
So you'd go cloud native, meaning you put your data and compute together in the cloud if time to value is everything. If the work is experimental or the data isn't that big or sensitive, you're choosing speed.
Correct. But you have to choose an agnostic or hybrid approach when security and compliance are non-negotiable. Think finance, healthcare. You choose agnostic when your data volumes are in the petabytes, making a move financially impossible.
And crucially, when the whole point is to build long-term IP that you absolutely must control.
Yes. And the reality which you see in the market is that about 80% of enterprises are already hybrid. It's the necessary compromise.
So what does that optimal balance look like?
It means you keep your crown jewel data, the petabyte scale, regulated stuff safe on-premise. You run your consistent base load AI work on your own cost-optimized hardware. But, and this is key, you keep the flexibility to burst out to the public cloud for experiments or to access some cutting-edge specialized hardware that you just can't get your hands on yet.
Okay, so if we're building this agnostic architecture, this fortress, what's the core principle?
It's all about strategic decoupling.
Decoupling what?
You have to separate 3 layers. The data layer, so your storage, the AI logic layer, which is the model itself, and the compute layer, the hardware.
And that decoupling is the key that unlocks everything.
It's the master key. It completely flips the old paradigm of moving compute to the data. Instead, you use these smart abstraction layers that make the data look like it's local to any compute anywhere in the world.
Which makes you compute flexible.
Exactly. Compute becomes a commodity. You can run your workloads on whatever hardware is cheapest or fastest or just most available at that moment. And that permanently defeats the vendor lock-in that's based on data gravity.
And the tools to actually do this are pretty mature now. It starts with the basics, right? Containerization, like Docker.
Yep, Docker ensures your AI application runs exactly the same way, whether it's in your data center or in an AWS region. And then you have infrastructure as code or IAC, like Terraform.
Which scripts the whole environment.
Right. Networks, storage, security policies, all in a single portable language. So you can spin up your entire environment anywhere, instantly.
But the one technology that every source we looked at mentioned as critical was Kubernetes.
It is the universal AI orchestrator.
Yeah.
It's probably the single most important piece of the puzzle. Kubernetes gives you a standard platform-agnostic control plane that just abstracts away the hardware underneath.
So it doesn't care if it's running on CPUs or GPUs.
Or where they are. It lets you run these really complex training jobs wherever the best resource is, and it moves seamlessly between on-prem and the public cloud.
Let's talk about some specific patterns that use these tools. The first one is zero-copy cloud bursting.
This is a really elegant solution. It's often done with data orchestration platforms like Alluxio. What it does is create a kind of virtual bridge. It lets a cloud compute cluster query an on-prem data lake on demand.
So instead of moving the whole petabyte,
You just fetch the specific bits of data you need for that one query. You get all the power of cloud compute without any of the cost or risk of a massive data migration.
the second pattern is even more ambitious, the global namespace.
This is the cutting edge. Solutions like Visas Data's data space create a single unified storage pool where all your data, whether it's on-prem and AWS and GCP, it all appears as one single folder.
The example in the material was incredible. Running AI inference on Google TPUs in the US and NVIDIA GPUs in Japan.
Simultaneously.
From the exact same data with no copies.
That is true freedom from data gravity. It fundamentally breaks the model.
But this amazing flexible engine needs good, clean fuel. And that brings us to data strategy, data mesh, and data fabric.
Right. The data mesh is the organizational, the cultural shift. It's about decentralizing data ownership. You give it to the business domains, and you make them treat their data like a high-quality product.
So it has to be clean, discoverable, secure.
Exactly. It's how you break down the data silos.
And the data fabric.
That's the technology layer that makes the mesh possible. It uses AI and smart metadata to automatically discover, catalog, and govern all the data across your entire hybrid landscape. So if the mesh is the organizational who and how, the fabric is the technical what and where.
Okay, let's bring this all together. Cloud agnostic isn't about hating the cloud. It's a strategic commitment to flexibility. And the #1 design principle has to be architect for exit.
From day one.
From day one. And that means you prioritize open source tools like Kubernetes or open models like Llama and Mistral for portability. And you make damn sure you retain full control over your own intellectual property.
And you see the smartest companies doing this right now. Citi is a great example. The financial giant, they use Google Cloud for speed, for modernization. But at the same time, they're building their own internal AI tools, and they're participating in open source projects like InstructLab.
So they get the best of both worlds.
They get short-term speed while making sure they have long-term control. It's the perfect execution of the strategy.
So the conclusion for you, for the learner, is pretty simple. Do not sacrifice your long-term control for short-term speed. You have to invest in the foundational architecture that makes you compute flexible.
And, if these patterns we talked about are ways to manage data gravity, the next frontier might be a way to solve it completely, and that's federated learning.
Okay, that sounds like a very elegant solution. How does federated learning, or FL, work?
It's a decentralized machine learning technique where the raw data never ever leaves its source. It stays inside its secure domain, like a hospital or a specific business unit.
So the data doesn't move at all?
Not at all. The central server sends out the model. The clients, the different domains, they train the model locally on their own private data, and then only the encrypted model updates, just the mathematical learnings or weights, are sent back to the central server to be combined.
So the massive, sensitive, petabyte scale data is never moved, it's never pooled together, and it's never exposed.
Exactly. It completely severs the link between data gravity and building powerful AI. You can train these incredibly powerful models on huge, diverse data sets without a single byte of sensitive data ever having to migrate. It is the purest and the ultimate expression of move compute to the data. That is what the architecture of true independence looks like.
That's it for our special deep dive into data gravity versus cloud agnosticism. We hope you now have a clearer strategic map for navigating hybrid AI architectures and avoiding expensive vendor lock-in. The path to performance doesn't have to mean sacrificing freedom. Now, a quick word for our builders. Stop marketing to the masses. Start briefing the C-suite. You've seen the power of AI Unraveled. Zero noise, high signal intelligence for the world's most critical AI builders. Now, leverage our proven methodology to own the conversation in your industry. We create tailored, proprietary podcasts designed exclusively to brief your executives and your most valuable clients. Stop wasting marketing spend on generic content. Start delivering must-listen strategic intelligence directly to the C-suite. Ready to define your domain? Secure your strategic podcast consultation now and find the link in the show notes. If this episode helped you solve an architectural headache, please take a moment to like and subscribe to AI Unraveled on Apple Podcasts or wherever you listen. We'll catch you next time.